Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. These are some review exercises about Chapter 7. Chapter 7 is about techniques of integration and improper integrals. So here we can easily expand x plus 1 square. It's x square plus 2x plus 1 over x dx. And then we can easily write it x squared over x, which is x, plus 2x over x, which is 2, plus 1 over x, and then integral of x is x squared over 2 plus integral of 2 is 2x, or just 2 times 2 minus 1, plus integral of 1 over x is ln x from 1 to 2. So we will have 4 over 2, which is 2 minus half, and then plus 2 times 2 minus 1, or just 2, and then plus ln 2 minus ln 1, which is 0. So we will have 4 minus half, or 3.5, or 7 over 2, plus ln 2. That would be the answer. Second integral. Here we cannot distribute the numerator over the denominator. So if we take u equals x plus 1, then du would be dx. And if I put x1, u would be 2. If x is 2, then u is 2 plus 1, which is 3. And then this integral would be from 2 to 3. And x is u minus 1 from here. And x plus 1 is u. So I have u squared. And dx is du. And now I can write it. I can distribute now. U over u square is 1 over u minus 1 over u square, or u to the power negative 2. The integral of 1 over u is ln u from 2 to 3. And the integral of u to the power negative 2 is negative. So this would be positive 1 over u from 2 to 3. And then the answer would be ln 3 minus ln 2 plus 1 over 3 minus 1 over 2. And you can write it as you like. For example, I can write it ln 3 over 2, or 1.5, plus, or it would be minus 1 over 6. If you add 1 over 3 minus half. Now here 1 over secant is cosine, so I can write this as cosine x e to the power sine x. And here I see that if I take u equals sine x, then du would be cosine x dx. And then this integral would be integral of e to the power u du. And the answer is eu plus c, or e to the power sine x plus c. Here I have a rational function. So I can take 1 over 2t squared plus 3t plus 1 and factor the denominator. So I have 2t plus 1 times t plus 1. So t plus 2t is 3t. And I can write this as partial fraction a over 2t plus 1 plus b over t plus 1. And I can replace t by negative half because it is the zero of the denominator, and forget about this. So 1 over negative half plus 1 would be 1 over half, which is 2. So a is 2. And if I replace t by negative 1 and forget about this, so negative 2 plus 1, negative 1. 1 over negative 1 is negative 1. So b is negative 1. And then I can write this integral as integral of a, which is 2 over 2t plus 1 minus integral of b, which is negative 1. I took the minus out, over t plus 1 dt. I'm solving for the students who know the previous 4 sections. So if you have any problems, why this method is used, how this method is used, please just go to see, for example, for this question, section 7.4, how did we solve the exercises about it. So ln 2t plus 1 over the derivative of 2t plus 1, which is 2 minus ln t plus 1. And that would be the answer, and you can cancel 2 with 2. You leave it like this, or if you want to write it ln 2t plus 1 over t plus 1 plus c, that would be also okay. Here x times ln, so we use by parts. So I take u, I call u equals ln x, and dv x to the power 5 dx. So du is 1 over x dx, and v is the integral of x to the power 5, which is x to the power 6 over 6. So this integral would be u times v, which is x to the power 6 ln x over 6 from 1 to 2 minus integral from 1 to 2 v du. So there is 1 over 6 outside, and 1 over x times x to the power 6 is just x to the power 5 dx. So this would be 2 to the power 6, and 2 to the power 6. When you divide over 6, you get 32 over 3. So it is 32 ln 2 over 3. And ln 1 is 0, so minus 0. Minus 1 over 6. Integral x to the power 5 is x to the power 6 over another 6. So 6 times 6 is 36 from 1 to 2. 2 to the power 6 minus 1 to the power 6, which is 1. The answer is 63. 63 over 36 is 7 over 4. So the final answer would be 32 ln 2 over 3 minus 7 over 4. Now here sine times cosine, this is section 7.2. Power of sine is odd, so I take u equals cosine. And then du would be derivative of cosine, and that's negative sine. And now I also change the values. So to change the values, if theta is 0, how to find u? So I write theta as cosine inverse u, and hence if theta is 0, no, there is no need, sorry. If theta is 0, I just put it here, and cosine 0 is 1. So if theta is 0, then u is 1. I just use this. And if theta is pi over 2, cosine pi over 2 is 0. So this would be, let me write it first as sine cube. I need only sine theta d theta, so I'll just take one sine here, and I put the minus sign here and outside. And all the others, I need them in terms of cosine. So I still have sine square, so I write it 1 minus cosine square. And this cosine square, I'm good with it. And now I can change to u. So there is a minus sign, and if theta is 0, u is 1. If theta is pi over 2, u is 0. 1 minus cosine theta is u, so I have u square. And cosine theta is u, so I have also u square. And this is du. So I can multiply. Okay, so I leave the minus outside. And from 1 to 0, 1 times u square is u square minus u to the power 4. Well, let me do something. If I change the limits of this integral, make it from 0 to 1, then this minus will disappear. So this is, in fact, integral from 0 to 1, u square minus u to the power 4 du. And the answer would be u3 over 3 minus u5 over 5, and from 0 to 1, from 0 to 1. So 1 over 3 minus 0 minus 1 over 5 minus 0, and 1 over 3 minus 1 over 5. You just add the two fractions and you will get 2 over 15. That's the answer. Now here, using section 7.3, I can choose x as 4 sine theta. And please study the section well to understand why we did this substitution. Derivative would be dx equals 4. Derivative of sine is cosine. So now I have dx. I need the square root. So what is the square root of 16 minus x squared? It is square root of 16 minus 16 sine square. I take 16 out. 1 minus sine square is cosine square. Square root would be 4 cosine theta. So this integral would be equal to dx is 4 cosine theta d theta. X square is 16 sine square theta, and the square root 4 cosine theta cancels. And I'll have 1 over 16, and 1 over sine square is cosecant square theta, and the integral of cosecant square theta is negative cotan theta. So that's the answer, and now I need to go back from theta to x. Well, sine theta is x over 4, and it is opposite over hypotenuse. So if I have a right triangle where this angle is theta, then the opposite side would be x, and the hypotenuse would be 4, and then the adjacent would be 4 square, which is 16 minus x square under the square root. And the answer would be negative 1 over 16. And now cotan is adjacent over opposite. So it is square root of 16 minus x square over x. So this would be the final answer. Well, here I have x with ln, so there is no choice for me except to use the integration by parts and take u as ln x to the power 2. And here to find du, I need to use the chain rule. So it is 2 ln x times 1 over x, and dv is x, so v is x squared over 2. And using integration by parts, this integral equals u times v, so it's x squared times ln x all square over 2 minus integral v du. And when I multiply v times du, 2 cancels with 2, x squared cancels with x, and I get x times ln x dx plus c. And integral x ln x is easy. I can do it also by parts. So u would be equal to ln x, and dv is x. So du is 1 over x dx, and v is x squared over 2. And now the integral would be equal to uv, which is x squared over 2 ln x, minus integral v du. So it is half, and x squared over x is x dx. So the integral is x squared over 2 ln x minus half x squared over 2. So I can write the final answer here. X squared times ln x to the power 2 over 2 minus x squared over 2 ln x, minus times minus will be plus x squared over 4 plus c. So we used integration by parts twice. Now I have e to the power 2x, e to the power 4x. E to the power 4x is e to the power 2x squared. So if I take u as e to the power 2x, then du would be e to the power 2x times 2, the derivative of 2x. And in this case, I need 2 here and half outside. So this would be equal to half integral. Now 2e to x dx is du, and 1 plus e to x squared is 1 plus u squared. So e to the power 4x would be u squared. So this is 1 over 2, and this is tan inverse u plus c, or half tan inverse e to the power 2x plus c, and that's the answer. Now here I haven't much things to deal with, so I will call the cube root of x u. This is in section 7.4, rationalization substitution. If I raise to the power 3, so u to the power 3 would be x, and then 3u squared du is equal to dx. So this integral would be integral of e, and cube root of x is u, and dx is 3u squared du. So I changed the integral from x to u, and I have u squared times eu. And I can do this by parts, and I can even use the fastest method, or the faster method we used to make a table. So we will take u as u squared. This is the function we are going to find its derivative. And e to the power u is the function we are integrating, dv. And I put plus minus plus minus. So the answer would be 3 times u square EU minus 2 times 3, so minus 6 u EU plus 2 EU with multiplied by 3, so plus 6 EU plus C. And you can replace u now by cube root of x. So 3 cube root of x square e cube root of x minus 6 cube root of x e to the power cube root of x plus 6 times e to the power cube root of x plus c. It will be interesting for me to find the derivative of this and prove that the derivative of these three terms would be equal to e to the power cube root of x. I find this problem interesting. If you find, do it to check the answer. If you find it too interesting, do that. I have power of the numerator is greater than the power of the denominator, so immediately I'm going to use long division. X squared divided by x is x. Multiply, I have x squared plus 2x. We learned this in section 7.4. Change the signs and add. So 2x plus 2 divide 2x by x, that is 2. 2x plus 4 and change the signs and add. So I'll have negative 2. So I can write this integral as integration of x plus 2, which is the quotient, then the remainder minus 2 over x plus 2 dx, and integral of x is x squared over 2 plus 2x, and integral of this is ln absolute value of x plus 2 plus c. Here I have x plus 2, x plus 1. Well, the power 20, I have problem with it. So I will take u equals x plus 1. So du would be dx. Let me see what would happen with this integral. X is u minus 1. So u minus 1 plus 2 would be u plus 1 to the power 2. And x plus 1 is u. So, and dx is du. So yeah, I can continue easily. U plus 1 is u squared plus 2u plus 1 times u squared. So this would be integral u2 times u squared. You add the powers u22 2u to the power 21 plus u to the power 20. And then the answer is u to the power 23 over 23, 22 over 22, and u to the power 21 over 21. And then you replace u by x plus 1. So this would be the answer. 2 over 22 is just 11. So I can write here x plus 1 to the power 22 over 11 and x plus 1 to the power 21 over 21 plus c, and that would be the answer. I have secant and tan and secant power 6, although tan is in the denominator, but I'm going to use the same idea in section 7.2. If power of secant is even, I take u as tan. So du would be the derivative of tan, which is secant square x dx. And now let me rewrite the integral. I have 6 to secant to the power 6. So secant to the power 4 is not needed. I only need secant square times d theta for du, and I will have secant to the power 4. Well, I know that tan square minus 1 is secant square. So I will have tan square theta minus 1. This is secant square. Is it minus 1 or plus 1? I think plus 1. Because sine square plus cosine square is 1. Yeah, so tan square plus 1 equals secant square. So tan square plus 1 equals secant square, and I have secant to the power 4, so this would be squared over tan squared theta. So this integral would be integral u square plus 1 to the power 2 over u square times du. And I believe this integral is easy, and we did the first integral maybe similar to it. U to the power 4, I just expand, okay, and then I divide u4 over u2 and continue easily. And do not forget at the end to replace u by tan x. This is a rational function again. Factoring the denominator, taking x squared as a common factor, I have x plus 3. So I will write x squared plus 8x minus 3 over x squared times x plus 3, following what we learned in section 7.4. I can write this as a over x, b over x squared, cx plus d over x plus 3. And I can find b quickly here by replacing x by 0, but not in x squared. So I'll have 3 in the denominator and negative 3 in the numerator. So b is negative 1. That's the only one I can find, the only coefficient. And to find the other coefficients, now I multiply by x squared times x plus 3. So 8a would be a times, before a, the left-hand side is x squared plus 8x minus 3 equals a times x plus 3 plus b times x plus 3 plus cx plus d times x squared. This is what happens when I multiply this equation by x squared times x plus 3. If you have any problem, please check again section 7.4. So I will here, I have ax times x, this is ax squared plus 3ax plus bx, but b is negative 1, so I replace it by negative 1, so I have negative x, negative 3 plus cx to the power 3 plus dx squared. And now I will take negative x minus 3 to the other side, so I will have x squared plus 8x plus x would be plus 9x minus 3 will cancel with negative 3. These two will be cancelled. I have cx cubed. Let me write it first. And then I have ax squared plus dx squared, so I can write it a plus dx squared, and then I have 3ax. So from here, comparing the coefficients, there is no x cubed in the left-hand side, so c has to be 0. For x squared, a plus d should be 1, because the coefficient of x squared here is 1. And 3a, the coefficient of x, should be equal to 9. So a is 9 over 3, which is 3. And if a is 3, then d is 1 minus 3, or negative 2. So I have a, d, c, and b. So I can write the integral, this integral, which is I, equals integral a over x, and a is 3. plus integral b over x squared, and b is -1. c is 0, and d is -2. So minus integral 2 over x plus 3 dx. And then the answer would be 3 ln absolute value of x. This is x squared -2. The integral is -1 over x. So this would be positive 1 over x minus 2 ln x plus 3 plus c. And that would be the answer. I have here also rational function, but this is an irreducible factor, irreducible quadratic factor, and this is also irreducible quadratic factor. So I will write 3x cubed minus x squared plus 6x minus 4 over x squared plus 1 times x squared plus 2 equals ax plus b over x squared plus 1, as we did in 7.4, over x squared plus 2. And now I need to multiply by the denominator, this one, x squared plus 1 times x plus 2. So I will have 3x cubed minus x squared plus 6x minus 4 equals ax plus b times x squared plus 2 and cx plus d times x squared plus 1. And now here, expanding, I'll have ax times x squared, that's ax cubed, then 2ax, then bx squared, then 2b, then cx cubed, then cx dx squared plus d. And now equating the coefficients. The coefficient of x cubed, a plus c, should be equal to 3. Okay. And x squared, I have b plus d. This should be equal to -1. And the coefficients of x, I have 2a plus c. This should be equal to 6. And the constant terms, I have 2b plus d. This should be equal to -4. So I have 4 equations and 4 variables. I have a plus c equals 3, 2a plus c equals 6. So if I just subtract these two equations, 2a minus a is a, c minus c is 0, 6 minus 3 is 3. So a is 3 and c would be 0, because if a is 3, then c is 3 minus 3, which is 0. For these two, b plus d equals -1, I do the same. 2b minus b is b, d minus d is 0, -4 minus -1, -4 plus 1, or -3. If b is -3, then d is -1 plus 3, which is 2. So these are the values of the 4 coefficients. And then this integral would be equal to integral of ax plus b. Well, a is 3, b is -3 over x squared plus 1. That's the first integral, plus the second integral. C is 0, d is 2, so I have 2 over x squared plus 2 dx. So I can write this as the first integral I can distribute 3x over x squared plus 1 dx minus integral 3 over x squared plus 1 dx plus integral 2 over x squared. Well, I can add these two, isn't it? I have negative 3 plus 2, so it would be just negative 1. There is no need to evaluate this integral twice. All right? No, I can't, because the denominator is different. So this is negative 3 over x squared plus 1, but this is 2 over x squared plus 2. So I cannot add these two. All right. So now the answer would be, for the first integral, I can take x squared plus 1u. So if you take x squared plus 1u, I need 2x. So I will have 3 over 2 outside. And this would be du over u. And the integral would be ln u, or ln absolute value of x squared plus 1. If you have a problem with this, use a usual substitution and you will get the answer. Minus 3 times integral 1 over x squared plus 1 is tan inverse x. And here I have 2. And integral of x squared plus 2 would be 1 over square root of 2 tan inverse x over square root of 2, and that's just a formula, plus c. So this is the answer of this question. I'll stop here not to make the video too long, and I will continue the other parts, the remaining, in another video.